Good morning, everyone. Thank you for joining us for the 7th webinar of the WeMake project, as the project starts to draw to its close this summer. Today, we're introducing you to a topic we haven't covered before, water efficiency. We've tried to make it as broadly applicable to industry as possible. We're happy and honored to have Deputy President of the Chamber of Commerce with us today, Chris Vassallo Cesario, who will be giving us an introduction, along with the CEO of the Energy and Water Agency, Manuel Sapiano. Over to you, Chris.
Good morning, everybody. Nice to see, as I said earlier, some new faces and some older faces. For those of you who are not familiar with the WeMake webinars, the objective is to assist companies in becoming more sustainable and more efficient, and thus more competitive. Sustainable manufacturing and conservation of resources are more than just energy management. Water management is expected to take a more pronounced role amongst the metrics for sustainability. Aside from an expression of green credentials, investing in water efficiency allows a company to secure its future cost base, particularly given that the Maltese freshwater is a resource under increasing strain, and its future abundance is not a given. There are various ways to carry out water efficiency investments in industries, and there are many applications of water to the manufacturing process. Processed water is used in the execution of manufacturing processes such as incorporation into the product, while cooling and heating water may be used for chilling water systems also. So today's event showcases brief best practices from 3 leading manufacturing companies, which will highlight the investment opportunities for companies, such as rainwater collection for heating and cooling. I encourage you all to take note of the monthly workshops and to reach out to the project team at the Malta Chamber and MBB if you want to participate in receiving the free consultancy services. So thank you, and I hope you will find today's webinar fruitful for your companies.
Thank you very much, Chris. Mr. Sapiano.
Thanks to you, and good day to all. So definitely, the WeMake project is an important project from the agency's perspective. First of all, because it strengthens the collaboration, the good collaboration which we have had with MBB and also the Chamber. And apart from that, also because we are addressing an important sector in our economy where we can support and provide support so that positive measures can be undertaken to optimize operations, leading to an increased and better level of sustainability, but also measures which can be financially sustainable in their own right. And therefore, we see this project as promoting what can be described as a win-win situation for industry, for the commercial sector, but also for the country as a whole. This meeting will deal with water. As correctly mentioned, definitely water has an important aspect in the processes of the manufacture, let's say, the manufacturing sector, for example. We can talk about water involved in processes, water involved in cooling, but also water involved in, let's say, what one can describe as domestic uses. So, the normal day-to-day life of employees. Therefore, we need to look at water from a number of different perspectives. First of all, and let's say the overarching measure with regards to water management is efficiency, water demand management. The more efficient we are, means that the less water we need to produce. And therefore, any volume of water which is saved is definitely relates to less energy requirements, less impact on our environment, and therefore, apart from that, also lower costs for the supply itself. So we need to start with efficiency, and that is important. But we can also look at let's say, other processes where alternative water resources can be generated, like rainwater harvesting, but we can also look at the treatment of water for, let's say, for the reuse of water. And here one looks at, let's say, the need at not just looking at water in isolation, because being involved, let's say, being involved in processes, being involved in cooling, being involved in other uses, there's also an important link between water and energy. And here comes the notion of, let's say, the widely noted notion of the nexus. So the links between energy and water. In Malta, we do not look at the nexus from the point of view of water for energy production. And sometimes it's much more from the point of view of energy for water production. Therefore, once more, any water saved, any water which requires less treatment is energy saved. But we also need to keep into consideration that water sometimes needs to be heated, and that also has an energy footprint. And therefore, what we are looking through this project is the possibility of looking at what is happening. So understanding from an agency perspective what is already happening in the sector. And that is why we are happy to have best practices also being presented during this webinar. Apart from that, we also need to understand better what are the needs of the sector. So eventually, what can be supported tangibly, practically, and what can be pragmatically achieved, so that we can develop and, let's say, guide our policymakers towards the possibilities of support for increasing efficiency in use, and how. So that can be an aspect of the discussion during this webinar, where basically, let's keep in mind that we are here, all of us, including from our side, we are here to learn, and not just through sharing experiences, but also to learn what the needs are and what the tangible, let's say, requirements of the sectors are. So therefore, this is an important webinar. We'll discuss an important challenge, and let's look at identifying win-win situations which we can promote, and also work together to get the necessary support for these win-win situations to be further promoted in the future. Thank you.
Thank you very much, Mr. Sapiano. Today we're going to start with a presentation by Seifert. We'll be moving on to a presentation by Tolly, then by Trelleborg, and we will be concluding with a presentation by the Water Services Corporation. I'd like to introduce Ruben from Seifert, who will be taking us through the best practices of his company.
Thank you very much, Tim. Thanks to this initiative for the opportunity also for us to showcase what we have done, and maybe also what we plan also to do in the near future. I'm going to share my presentation. So share screen. Good. So we're going to speak a little bit about some initiatives which we are also taking at Seifert with regards to not only water, of course. It has already been mentioned already in these few minutes that we have been online. The need to conserve energy, to save energy, saving water indirectly is also saving energy, given that a lot of our water that we use is also coming from reverse osmosis, which are operated by electricity. So everything comes along as a nice chain. It's quite convenient actually to save water in order to contribute also to save energy at the end of the day. A little bit of introduction about Seifert. It's a family business established since 1965. It started in Germany and has been operating in the Halfar industrial estate since 1991. We're employing 230 employees. And Seifert Systems is a one-stop shop for a number of processes We provide product design, including also the design of controllers. We do EMC testing, sheet metal fabrication and surface treatment for cleaning of sheet metal and powder coating, mechanical and electrical assemblies. Seifert is represented in quite a wide area around the world, and the reach is quite widespread. So we have also other companies distributed around the world. Our contribution as Seifert has been going quite for some time with regards to initiatives, let's say, in favor of the environment. Starting off, I remember it was in 2015, where there was the installation of 1.2 gigawatt hour installation of photovoltaic panels, saving about 860 tons per year of CO2. We are also carbon neutral since 2020. So that doesn't mean that we should stop there, but of course, we need to make more, we need to do more in order to continue to reduce our emissions. I will explain very briefly later on. Our technologies are also, especially in our new equipment that we are investing in, is taking care of circular economy, or more efficient also use of water, not only of energy. And we are ISO 14001 certified since 2015. So it goes without saying that we have KPIs, and we need also to, we are also audited, of course, we need to keep also up to the standard. Some very quick examples, not going to spend too much time on this one. Some initiatives which I have taken up to now, which are a totally new compressor system, for instance, which is much more efficient than the previous one, and that is contributing to 60% more improvement, 65% more improvement than the current, than the older one, because actually this one, as you are seeing, it was, this photo was taken when it was still pegged. It is now running and is already giving us some good improvements over there with regards to energy. Plus, it is also will be incorporating a heat recovery system that will be used in the heating of water, actually later on, for another new equipment that I will mention also shortly. Another initiative, Industry 4.0, included in the setup of this sheet metal storage system. It's an intelligent system also that speaks with DRP to coordinate orders, also to design parts on sheet metal basically. That means that scrap of sheet metal will reduce considerably, because the human programmers were already doing a good job, but the machine is doing it because it also takes orders also from the future basically, and then it can make the design of parts in a more efficient way, thus reducing sheet metal waste. This is the adherent testing equipment, expected 2024. It is ramping up. Basically, this is a surface treatment plant. A surface treatment plant is used to treat the sheet metal. The sheet metal that is basically the casing, and also there are some internal parts that are used in our industrial air conditioning systems. That is the major product that is produced by Seifert Systems in Malta. There is the need to clean the sheet metal to prepare it for the other coating processes. This is a system that will go very much also into the project that I'll be mentioning very shortly with regards to water, because it will be using water from this reservoir that we're going to mention. But all in all, it will be using circular economy because heat is going to be reused both from the compressor system and also within the equipment itself. And as you can see, there's going to be energy savings. So CO2, there's going to be a reduction also by 500 tons annually. So it is sustainable, I might say, not only from an environmental point of view, but also from a financial point of view, which it is very important also to take care of that. Carbon neutral since 2020, taking care to measure all scopes 1, 2, and 3. Yes, we are carbon neutral since 2020. The targets that we have put that until 2026, scope 1 and 2 will decrease to slightly below 300 tons of CO2. Scope 3, of course, there are other targets which we are controlling together with the respective stakeholders. So that is just a brief of what Seifert is doing also in general with regards to sustainability in general. Coming to the subject, basically that we are discussing today, our main project with regards to water is that since a lot of new developments are going on in the factory, we thought that it would be just in time to make the necessary arrangements to design reservoirs for the target to be as much as possible water neutral, basically, so that we could use our own water as much as possible rather than using mains water. So that is the ultimate idea of this project. And we started off by, of course, seeing what the water consumption is. We are measuring water consumption on a daily basis, of course, to see whether there are any anomalies, first of all, that are cropping up each and every day. And considering the last 3 years, one can see 2022, for instance, there was an increase. There is the blue part and the red part of the chart, of the bar. Those are two different areas which are being monitored on a separate manner because they are containing also two different processes, two different production areas. And the blue part, as you can see, is contributing to a little bit of an increase. That after analyzing the situation, it was correlated into the fact that there was more production time. Basically, there was an increase in workforce, so that contributed to the increase in water consumption. The point here is that monitoring, of course, will give you the opportunity to identify any anomalies, and then you take action accordingly. The per capita, the per person consumption remained approximately the same, all in all. So coming to the project itself, this is the roof, the nice roof of Seifert Systems, which already giving us some contribution with regards to energy. This roof was seen, of course, to be big enough in order to give us some benefits with regards to water catchment. And a calculation, a run of calculation was done basically in order to see how much water we could gather on a typical year, or on a bad year and a good year, as we're going to see, and then say calculate a little bit of the size for the reservoirs. I'm saying reservoirs because the intention is that we make a total of 2 reservoirs as a start. So we have a total of 7,450 meters squared. There you're seeing that half of the roof, of the big one that is being marked, the reason being that the design of the roof is designed in such a way that the tilt is going to the back side. The back side is the top, what you are seeing at the top of the screen. That doesn't mean that in the near future we're not going to take care also of the front side of the factory, but we are taking it in a stepwise manner. So the idea is to have 2 reservoirs. There's reservoir A and reservoir B for a total of 2,400, almost 2,500 meter cubed. They will be done in 2 phases. The designs, let me say, the preliminary designs are ready. As you can see, that area is still under construction. And the top part that you are seeing on the photo is actually the back side of the factory. And Reservoir A will be done first in phase 1. Reservoir B will be done in phase 2. The idea is to have also Reservoir A to overflow into Reservoir B. Some calculations that we did, actually we also had the help also of a well-known engineer in Malta for water, Engineer Cremona. And we also measured we compared the consumption versus the precipitation on a good year and on a bad year, let me say. And quite conveniently, 2021 and 2022 represented quite some data which we can use. We compared it, so we compared the precipitation to the consumption and saw how much would the reservoir have a surplus sort of, and one can see that on a good year like it was in 2021, we could end up on a surplus in December. Considering that, however, the assumption is that you start from 0 on January. All right. If it's not a good year like it was like last year, for example, 2022, we would end up with a deficit. However, of course, if we had these, no one would consider that 2022 would end up with 2021. So whatever ended up in December 2021, that would have to add up also for the start of 2022, and we would still end up with a plus. This means that the reservoirs are there. It is, I think we have heard it also in the media, also quite some education that we have received also that was presented by the authorities. The need for water reservoirs. A water reservoir is there, it will catch water and it can be used rather than having it run off in our streets, flooding everywhere. So it is something that one needs to consider seriously, in our opinion. In fact, what we said is that, I mean, the reservoir by itself, the big reservoir is going to cost us something like 130,000 euros. The return on that investment is going to take a very long time. But in our conscience, basically, having this setup here will mean that we will really contribute in an active manner to saving water, using water which is caught from rainwater on the roof, basically, rather than as much as possible using mains water. So it is at the end of the day still feasible. It's not only, and by the way, I forgot to mention also that this water is also going to be used, because this is also one of the nice things, it is also going to be used in the surface treatment equipment. So the surface treatment equipment that is going also to heat up the sheet metal and clean the sheet metal is going to get water from the reservoir. It's going to heat the water also through solar collectors, catching heat also from the machine itself and also from the compressor system. It's a very nice system. It's a total sustainable equipment with sustainability in mind. So we look forward to have everything in place, and maybe in the future we can also present this in a live manner. It would be our pleasure. It is also, to conclude, it is if one needs to do things in a holistic manner, it is we have also to take care not only with big actions like having new equipment that is more efficient in the use and the reuse of water and energy, but sometimes also small things can have some effect, and that is education, training, of the workforce, of ourselves also, that is, because we are part of the workforce, in the efficient use of water. Just a very simple example is shown over there. There is a note, if a flushing is leaking, all right, please report where, all right? And I can give other examples that we have over here that are effective, because then someone sees water running out, all right, or sees some signs of leakages, they can report immediately to the right person and tackle it right away. So even small actions can lead to savings, because, for example, a leakage, if you do not see it immediately, or you do not monitor water consumption, you will not see this until it becomes quite evident, and that might be also a little bit too late. So this is our message. We look forward to have these reservoirs, because they will help us to save water. They will help us also to have a process, a new process that will be in place, and also the small actions that can result in also effective actions. And that is from my side. Thank you very much for your attention.
Thank you very much for that extensive presentation, Ruben. We really appreciate it, especially the level of detail. I'll hand over now to Mr. Olaf Zara of Tallinn for an overview of the rainwater collection system.
So let me share my screen. Oops, daisy. Oops, started in the middle. All right. So thank you for the invitation to basically present Tolly's water reduction initiatives. So I'd like to introduce Tolly products to start off with. We are a supplier of luxury packaging to the beauty industry. We supply packaging for color, cosmetics, skincare, and fragrance. Our headquarters, we are a Maltese company, so our headquarters is in Malta and our main factory is in Malta. However, we have manufacturing facilities in Malta, China, and Korea, and sales offices in the US, UK, but basically in the US, Europe, and Asia. Our sustainability initiatives basically are group-wide, but today I'm going to be focusing on Malta. So basically Malta, we're a vertically integrated factory. We are quite a large injection molding factory, and as we know, injection molding needs cooling. So this is basically where water really comes in. But because we're vertically integrated, we've got extensive decoration and assembly capabilities. Our focus has been not specifically on water, but basically on CO2 emissions. We started in 2017, and basically we've had some interesting results, especially since we basically rebuilt our factory in 2019. But some of the initiatives that we've done, basically, I think there's a common trend here. We've installed PV panels on our roofs. We've switched all our lighting to LED. We're switching basically all our equipment, and we basically have 60 molding machines, so it's quite the task from hydraulic to electric. These basically are about 80% more efficient than ton for ton, basically more efficient than the equivalents. So an electric molding machine consumes about 2 kilowatts an hour, whereas a hydraulic injection molding machine can consume up to 20 kilowatts an hour. And let's move into basically the water part. We built our factory on top of a 3,000 square meter reservoir, which basically allows us to harvest water, but also provides a lot of our cooling. So what do we use water for? Number one important thing, as I said, our focus is on CO2 emissions, but we've heard already twice, CO2, basically water production produces CO2. And one of the things that we have done at Tolly for the last now 5 years is basically we have an internal CO2 cost. There's an internal price for CO2, and that price actually gets added to the return on investment. So basically what we have done is we've given sustainability initiatives an unfair advantage, if you like, because we're not only calculating the return on investment in monetary terms, but we're also giving a monetary value to the CO2 emissions. So if we're saving on emissions, basically that gets calculated into the return on investment and basically gives sustainability initiatives an unfair advantage. We're using water basically for 4 reasons. Number one, well, 2 reasons. One is process. Cooling is by far the biggest use of water we have at Tolly Products. We do have some lacquering lines at Tolly Products, and we use water for spray abatement, so to catch any overspray and basically take it out of the system. And we have an area where we are actually cutting and finishing mirrors. This produces silica, so we need to use water to wash it off. And this is the 3rd use for water, and obviously domestic use. So basically, what have we done? We've basically, as I mentioned, built our factory on top of a 3,000 cubic meter water reservoir. Basically, this is situated below the ground, so we're taking advantage of thermal transfer. So basically, most of our cooling today is being done by this water reservoir. Obviously, we have chillers that come in when the reservoir doesn't cope. However, in winter, we're basically using only thermal transfer for cooling, and in summer, we're using about 1/3 of what we used to use in the past. When I compare this to the previous system, basically we had a system with 30 cubic meters of water, and we were basically chilling the water directly. It was going straight into our chillers, reducing the temperature to 7 degrees, being pumped into the machines, coming back at 24, 25, 26 degrees. And we're going through that cycle all over again. So we had a delta of about 19 degrees. Today we have a delta of 4 degrees. So the electricity consumption reductions and the reduction in CO2 is phenomenal. So basically what we have today is we have heat exchangers, which separate the process water from the reservoir water. So we have very little process water and a lot of water in the reservoir. Basically, this gives us a couple of advantages. Number one, we do not need to treat the water in the reservoir, which is an advantage in 2 ways. Basically, there are no chemicals in the water, so any water losses are not going to damage aquifers or groundwater. And also the fact that we have basically a closed loop system for the process water means there are no losses. In the past, these losses used to be anywhere between 40 and 50 cubic meters per year. The reservoir is being replenished by rainwater harvested from the roof, which is basically the biggest part of the replenishment. However, we're also capturing wastewater from our chilling and air conditioning. These produce a lot of wastewater, and it's going back into the reservoir, also being used for process use. We have a building management system. We heard before, again, monitoring is very important. So we have a building management system, which basically is monitoring our water use. Not just our water use, water and electricity mainly. And basically we are looking at the daily reports. If there is any abnormal use, it is being flagged up and attended to. So this is basically what we are doing now, what we are planning to do from this year onwards. Basically, we have a project ongoing at the moment to capture our reverse osmosis wastewater. We treat a lot of our own water basically for cleaning purposes, and at the moment the wastewater is going to waste. It's a lot of water. So basically, within the first quarter of this year, we have a project that will take that wastewater and pump it back into the system for domestic use. Obviously, when I'm talking about domestic use, we're not talking about potable water. We're talking about water for basically bathrooms, etc., etc. Also, as I mentioned, we are harvesting a lot of water. However, today we do not know how much water we are harvesting. So the second project we have for this year is we are going to install flow meters to capture this data and understand exactly how much water we are harvesting and basically to be able to optimize the system. So that's my presentation. Thank you very much for your attention.
Thank you very much, Olaf. Now we move on to our final set of best practices from Trelleborg. Mr. Neville Grima.
Okay, thank you, Tim. Yes, we are going to focus during my presentation about water, and namely about one of the main processes which we have done and we have perfectionized to basically save water. So in a minute, I'm going to share my presentation. Okay. So first of all, a brief introduction to us, Trelleborg. We are basically a Swedish group producing any types of elastomers, and it mainly produces components which can seal, protect, and be of an advantage to buildings, automotive, aircraft, and any type of other engineering. Mainly, there are three divisions now at the group, which are Industrial Solutions, Sealing Solutions, and Wheel Systems. We form a part of the Sealing Solutions. So our Malta plant is called Trelleborg Sealing Solutions. Okay. This is our site at, actually it's our main site at Khalfar, because we have another site at Marsa, which is used for mixing and R&D. And this is a little bit of our history. Not a little bit, because as many of you might know us, in the past we were called Doughty. So we have more than 60 years history in Malta, and we were called Doughty because it was opened by Sir George Doughty, at that time servicing the British military. This slide shows the major milestones throughout these years and basically step up to the current times. As you can see also, we are diversifying our product to be able to change according to market necessities. This is our company profile. Basically, we employ around 550 employees, and we ship out 25 million seals per week. We are very famous for producing O-rings, as many of you might know, but as I said, lately we have been diversifying and moving away also from the automotive market because of the challenges ahead, especially with the electric car. So these 25 million seals are not all of them O-rings, but they are coming in all shapes and sizes currently. This is our customer base. Maybe a lot of you can recall a lot of famous brands here, like Bosch, ABB. These would be all our customers from Malta. As per Trelleborg customers, they would be all over the globe. So these are limited customers only to our Malta plant. Now we're going to focus on a project which we have done in the recent years, and we are continuing to expand. and it was named as a best practice in Malta. So, first of all, a brief explanation of our water process. We have this reservoir at the bottom, which has a capacity of 10,000 cubic meters. This reservoir is filled up by rain harvesting. It can be filled up by mains water, and it can be filled up also by Bowser water. And we extract water from it, and there is a circulation circuit around the whole premises. Now, that water is circulated through our hydraulic equipment, where we cool off hydraulics. We separate the hydraulic cooling circuit heat exchanger from the rest of the needs of the chilled water, so that we use only chilled water where it is only necessary. The rest, we cool it with this water. By dispersion and by geothermal effect, this water cools again, and its temperature is basically good again to use to cool off hydraulics in our equipment. Since it is also a second-class water, we use it also for sanitary use, basically in flushings. And the third part is that we use it for one of our processes. And that is where we are going to focus in the next slides. As you can see also at the bottom, the reservoir is basically segregated. It is divided into two sections, namely one 30% and the other 70%. And the 30% part is continuously overflowing into the rest. This is done to basically trap any debris that could flow into the system, and also we make sure that we have a 30% of that reservoir always full up, because we can also have the facility to connect it to a fire engine if the case would be needed. So this is the part of the process where we focused our efforts on, and we learned that it consumes the majority of our water. As you can see in that photo, that is a centrifugal finishing machine where we would throw a mix of unfinished product, namely O-rings or seals, and ceramic media. That machine would have its bottom, we call it the tub, which begins to spin and rotate for a number of hours. It could take even hours. At the end of that cycle, our O-rings would be finished, as I will show you in the next slides. However, this process needs to have a constant flow of water because it is a process of friction. Its benefit is friction. So if we leave it without water, in a few minutes, all of it would heat up and it will destroy our product and even our polyurethane lining. So it constantly needs water. And we have quite a lot of number of these machines. So you can imagine the consumption of a constant flow of water running for, yes, it could be 24 hours a day. So we decided then to do something about this process, since we learned that it is the main culprit of our water usage. For information, this is the before and after of the process. So you can see that the rubber seal is much more finished after this process. But then we go back again to our effluent analysis. And what we learned is that water coming out of that process would have an amount of undissolved ceramic solids in it that, if left for a certain amount of time, they would settle at the bottom. The two beakers shown there are one just extracted immediately after use, and the other one left for an hour or so. And you can see that it returns clear with the undissolved solids at the base of the beaker. So there we have understood that what we need to do is to remove those undissolved solids, and there is an advantage because we know that they are heavy and they settle at the bottom. So this is what we did. It's a schematic diagram of our water recycling plants. And what we did is we gathered all the water into an underfloor reservoir. This is not a very big reservoir. It mainly is around 2.5 meters cubed, where we dose that water with a coagulant agent to facilitate our process. And as soon as that reservoir begins to fill up, we pump that water into this large funnel that we are seeing. That large funnel type reservoir basically separates solids from liquids. As you can see at the top, it overflows into another tank, and at the bottom, we dispose of solids in conjunction with the local regulations. Basically, it's inert ceramic media, but we still need to have certificates to dispose of. But we recover the water from the top. Water from the top is then overflown into another set of tanks, and these all have their settlement time. As you can see at the bottom of each tank, there is also a valve which opens up every day to remove the solids settled in each one. That amount of water is then returned to the initial reservoir so that no water is wasted. The last stage of this recycling plant is a sand filter, where a regeneration of that filter takes place every 3,000 meters cubed of production. The backwash of that water again returns to the first reservoir, so that we make sure that we don't waste any water, even the backwash itself. This is how it actually looks, and to date we have constructed 3 of this plant. So on the left-hand side, we are seeing the settling tanks, and on the right-hand side, we are seeing the large funnel-type tank where we separate the initial separation of solids to liquids. The main characteristics of this plant can be seen in this slide. However, I would say that the main advantage was that we do not need any consumables, for example, like filter changes. It is made up only of settling tanks, and the last stage as a sand filtration, and the only running costs would be minor electricity, because we still inherently need to have electric pumps for circulation of water, so we are only adding a small number of pumps and electric energy, which are basically used only during backwash. And we also, as a running cost, incur the cost of coagulant agent. However, this is also an inherent cost, because if we didn't do anything, we still couldn't have disposed of what this effluent into our drains, and we will still have used coagulant to try to trap solids before letting them into our sewage pipelines. So basically, the running costs have only been added by a minimum here. The results in these years have been nearly dramatic. As you can see, we started off by consuming around more than 30,000 cubic meters of water each year. And now we are stating that we are measured beneath the 10,000 cubic meters. One has to realize that new projects come in every year, new production processes, and when they begin using water. So we then take a little bit of time to mitigate that usage and reroute again our water system to make full use of our efficient system. So that is why some years do fluctuate from one another, but we are now settled in a consumption which is basically 1/3 than what we used to consume in the past. And the future, we are expanding. We are basically beginning to construct another production block, which will have its own offices for production use, and we are going also to have another new administration block. This is being done exactly next to us. Apologies for those of you who can hear the construction noises, but that is the purpose. And we are keen to continue our process in saving water. So we are going to have an additional 1,000 cubic meter reservoir in this building. We are increasing our metered points so that we understand what is causing water consumption. We are extending the use of second-class water to other processes, but maintaining a good quality of the second class of water. And on top of that, we are going to add another new water recycling plant so that we can cater for the increased capacity. That was it. I hope you enjoyed our presentation, which concentrated on water consumption. And I would be available if any of you would need to ask about any aspect which you found interesting. Thank you for listening.
Thank you very much, Neville. That raises a good point. If anyone has any questions, we can make time to go over them at the end of the session. Just type them into the chat and we'll get to them. I see someone has already raised their hand, in fact. Go ahead and ask any questions now if you have them.
Hi, good morning, everyone. Here speaking Serna from Environment and Resources Authority, ERA. I would just like to thank everyone for great presentations. They were really insightful. And I would like to also point out for the last presentation from Trelleborg that I think this water recycling plant, this is just my opinion, could be very useful for separation of agricultural waste from solid and liquid, and for the future implementation in urban wastewater treatment plant, which I believe that that Eva and Mr. Manuel and Anna-Marie Gretsch are familiar with the current proposal and ongoing revision. So I just wanted to point out that I think that, correct me if I'm wrong, but I think that this water recycling plant could be also very useful for water reuse, which is also part of the Urban Wastewater Directive. So just wanted to express my opinion with regards to this. Thank you.
Thank you very much for that intervention. It was good to have another institutional perspective. And no problem, Neville, we didn't hear any background noise during your presentation, actually. It was all very clear.
Okay.
Good to see.
Okay, thanks.
Yes, good to see the savings achieved by Trelleborg. On that institutional note, we'll now turn to the Water Services Corporation, Engineer David Sacco and Trevor Giles Bray.
Good morning. So first of all, I would like to applaud the efforts of the three companies that have portrayed their initiatives to save water. And I will be presenting WSC strategy for producing this very important resource, water, and also the collection and treatment and reuse of the byproduct, which is wastewater. Some facts about water services. WSC was formed in 1992 through the merging with the Waterworks department at that time, with the mission of producing and distributing potable water to meet the nation's requirements and the accompanying expected water quality standards. In 2006, the drainage department was merged with WSC, thus expanding the responsibilities of Water Services Corporation to cover the collection, treatment, and reuse potential of the wastewater in an efficient way. WSC currently owns and operates 4 seawater reverse osmosis plants, 1 brackish water polishing plant, and 4 sewage treatment plants spread around Malta and Gozo. And we have a workforce of around 1,000 employees. So, a brief overview over the water production. As I said before, Water Services Corporation has 4 reverse osmosis plants located at Pembroke, Lapsey, Chirkawa, and Hondo, producing around 22.8 million cubic meters of water per annum. This is supplemented by groundwater extracted from circa 140 boreholes scattered around Malta and Gozo, which from their part they contribute to the mix 12.7 million cubic meters of water per annum. These sources are blended together in our 18 reservoirs currently in operation, mixed to a ratio of around 64:36. They are then obviously chlorinated and distributed through our water pipes, which the network currently extends to around 2,500 kilometers. However, WSC has not stopped there and has also continued to invest in its infrastructure to improve both the capacity and quality of the water it produces. First initiative, and perhaps one of the most important, is the increase in the current reverse osmosis plant capacities. Starting with Lapsey, the initiative has brought the plant from an estimated 19,400 cubic meters per day to up to a 30,000 cubic meters per day design capacity. The plant in Chirkawa will increase from 11,600 to 17,500 cubic meters per day. We have Pembroke, which is the largest plant, which will be going up from 43,000 to 56,000 cubic meters per day, and also the construction of the new Hondo RO plant in Gozo, which was commissioned last year with an overall production of 9,000 cubic meters per day. However, this is not all. We are going from 74,000 up to 112,500 cubic meters per day overall for the production in Malta and Gozo of waste of water through desalination processes. However, this is not the whole picture. The initiatives do not stop there. We have the Pembroke Taqali tunnel, which I'm sure you all heard about, which is in the final process of completion, and it is expected that it will come online later on this year. We also have planned in the pipeline an expansion of the current Chirkawa Taqali transfer line due to the enhanced capabilities brought about by the Hondo RO plant, and also the increase of the pipeline capacity between Taqali and Rendi, thus giving Water Services the flexibility of transferring water from Gozo till Rendi. So it will give a further greater flexibility in the water mixing potential. What is the result? The result is the lowering of the chloride levels throughout Malta and Gozo from the around 500 ppm level to around 300 ppm level. Coupled with this, Water Services is also planning to rehabilitate 2 of its reservoirs, one located in Fiddin and the other one in Naval in Halluqa, which is nearly completed, which will boost the current reserves by a further 30% from the current levels. Tying in with the previous slides, we need to take a look also at the trends relating to the specific power of the reverse osmosis plants. Taking in consideration the newest addition to the lineup, Hondo Arrow, this plant was conceived as the basis of power consumption best practices. In fact, the result is a 20% more efficient plant compared to the others. This factors in with WSC's plan, which was launched in 2021 to continue boosting the energy efficiency, pushing down the level of consumption in kilowatt hours per meter cubed from around 4 to around 3.8 by the end of 2023. This obviously ties in with the overall trend in reducing the amount of energy consumed and producing even more levels and amounts of water, taking into consideration the improvements done along the years. So net effects of the water production upgrades, we have an increase in production capacity of our RO plants, improvement of the quality of water that is being supplied to our customers, reduction of the energy requirement for the distribution and also production of water, notwithstanding the increase in capacity of the production, increase of the flexibility and mix of the water sources between Malta and Gozo, and also improving the water quality throughout Malta and delivering a more uniform quality throughout. And finally, also the increase in the level of water reserves available to Water Services. Shifting now to the wastewater aspect, obviously, if you're using water, you are generating the byproduct, which is wastewater. And as you all well know, WSC operates 4 sewage treatment plants. We have the largest one in Barkat, which treats around 55,000 cubic meters of wastewater per day. We have Sant Antnin, which has been recently commissioned and it is starting up operations with a design capacity of around 17,000 cubic meters per day. We have also the Chumnija plant in Nalliha with a design capacity of around 6,700, and Russell Hobbs Gozo with a design capacity of around 6,000 cubic meters per day. As you also know, the 3 major plants in Barkat, Chumnija, and Russell Hobbs have wastewater further treatment equipment installed to produce new water, which is intended for agricultural use. And I'm happy to report that its uptake till now has been very encouraging. WSC has also taken into account of this and has plans to increase the current capacities for Barkat plant in the next few years to increase the capacity from the current 9,000 cubic meters per day peak design capacity. We have also plans for Chumnija and to boost the 6,000 cubic meters per day, and enhancing that is the current capacity of Russell Hobbs for Gozo of around 3,000 cubic meters per day. So what are the effects on wastewater treatment process being highlighted in this slide? So we have the incoming wastewater, which is composed of urban waste, the industrial wastewater coming from the general industry in Malta and Gozo, and we have also the farmyard waste, which is passing through the sewage treatment plant process, producing the byproducts, effluent discharge to sea, the new water, electricity as a byproduct of cogeneration, and the solids, which are the end product that are landfilled. So the effect of treatment capacity is dependent on the amount of water that the plants are receiving and the load the concentration of the pollutants present in this wastewater. So if we have a reduction in the treatment capacity due to higher loading of the wastewater, this will have a negative impact on the process, thus resulting in a worsening of the quality of the wastewater effluent discharge to sea, lower amounts of new water produced, similar impact on electricity production, and also a worsening of the quality of the sludge that is landfilled in Malta. So as you can see, the ripple effect of non-conformant wastewater coming into the treatment plants will have a detrimental effect on the byproducts produced by the treatment process. What are the issues affecting the operations? One of the most important ones is the fats, oils, and greases. As you can see from the photo on the slide, a pipe practically clogged by solidified fats and greases. This originates generally from restaurants, hotels, canteens, and other food manufacturing industry, and tends to deposit over time and solidifying itself in the process, obviously causing a blockage in the sewage, in the wastewater network, causing nuisance to people and residents around. Apart from that, the high FOG levels also affect the treatment process by overloading the primary treatment and effectively hampering the treatment efficiency of this primary part of the process. Thus, knocking on the second part of the process, making it more difficult to treat to the desired level of quality. Other factors affecting operations, saline water. Perhaps it's not so much well known. However, the presence of large amounts of chlorides in wastewater does have an effect. The sources of this water, of this pollutant, is generally pooled backwashes and also rejects of water softening plants due to the regeneration of resins, and also brines from reverse osmosis plants using as their feed water high chloride sources such as saline waters and also seawells. What are the effects of saline water on wastewater treatment? It affects the organic removal efficiency and sludge settlability in sewage treatment plants. It also increases the corrosion of metal pipes and metal equipment throughout the wastewater network and also in sewage treatment plants, and also increases the cost to produce new water. Another factor that affects STP operations is chemical oxygen demand, which similarly to the FOG, this parameter translates to a higher organic load of the wastewater treatment plant, and the source of COD is generally prevalent in food and beverage manufacturing, laundries, wineries, and pharma companies. The organic load hampers the sewage treatment process by overwhelming the aeration part of the process, and obviously it is not treated up to the level that is required. And as a byproduct of high COD effluents, we also have higher amounts of sludge produced, thus also impacting the solids management of the sewage treatment plant. Tying to this, how do we prevent non-conformant water? We have the discharge permit unit, which I form part to it, which is tasked to regulate discharges and control the discharges of industrial wastewater. We have currently around 14 people, and we are expanding our capabilities and recruiting additional staff. And our work involves in performing inspections, generally as surprise inspections, and also involving collection of samples from the industry in general. The domestic, the requirement of the discharge permit is applying for a permit and obtaining a permit. We have two types of effluents being produced. As you can understand, the domestic effluent, which is the wastewater coming from toilet sinks and showers, and also the trade effluent, which is the wastewater produced from industrial and commercial operations. And it is this water that we are interested in and we need to regulate from our part. The law stipulates that all entities producing this trade effluent need to obtain a public sewer discharge permit. This requirement applies to all non-residential entities, such as farms, hotels, factories, hospitals, restaurants, fuel stations, and any other commercial establishment that produces such wastewater. And in order to bolster the effectiveness of our work, we are upgrading and reviewing the current law, which is expected to be enacted into law further later on this year. And the new law will be including some changes. First of all, removal of the application fee currently present. Trade franchises will be divided into different categories based on the type of operations and the volume of water discharged to sewer, referring to the trade effluent. Introduction of a number of fees in case of non-compliance to the law. Penalties introduced on exceedances found when non-conformant samples are collected, and also waste carriers are to discharge only at designated points and need to be registered with ERA. Some photos showing our efforts in improving the enforcement efforts being done. We have top left a new discharge point where these Bowsers will soon be using to discharge their wastewater into. We have also the monitoring stations, which are currently implemented. They are spread throughout Malta and Gozo and are effectively monitoring wastewater on a minute-to-minute basis and relaying the data back to us so that we have a better understanding of what is the quality aspect of the wastewater being monitored. And as you can see, our work also involves on-site testing and collection of samples using different methods and different instrumentation. Tying in with the overall scope of this seminar, I want to mention some common treatment technologies that we encounter out there in the industry. And the most notable implementations involve grease traps, which are perhaps one of the most basic ones. Their use is to remove the fats and grease component, especially in the food and beverage and restaurant industry. We have also oil water separators, where they are used for removal of petroleum hydrocarbons from wastewater. Sedimentation tanks, similar to what the previous speaker was mentioning, removal of solids. We have also miniature aerobic STPs for removal of solids, COD, BOD, and nitrogen. Vacuum evaporation, which is also being used to concentrate waste, and this is generally tied in with concentrating the wastewater and then exporting for further treatment or destruction. We have also coagulation sedimentation for removal of solids and COD, advanced oxidation, again for removal of solids and COD, and also chemical precipitation to remove heavy metals from the water column. From our part, these are not the only technologies available. We advise to all entities interested in installing or upgrading their wastewater treatments to seek expert help, both present locally and abroad. From our end, we also we offer our advice to make sure that the treatment technology that you are suggesting to use is in line with what is required, and if we are also available to answer any queries or questions in relation to this subject. These are our contact details. If you would like further information, please do visit our website or send us an email or give us a call. Thank you very much from our end.
For providing the institutional perspective. With the remaining 10 minutes we do have one question from Milan Haluska, who's asking about what's holding the WC back from using more NEWater in industry.
Well, effectively, the primary use of NEWater was targeted for agricultural use, and to be fair, currently we are at capacity. However, as I mentioned in my presentation, we do have plans to expand the production capacity of NEWater. However, I wanted to emphasize the point that the production of NEWater is not a constant science, such as RO production, for instance. It is heavily dependent, as I said in my presentation, on the incoming water and the level of compliance of the incoming wastewater to what is the design parameters of the plants, which will obviously have detrimental effect on the production capacity and also quality of NEWater. So yes, we do have some plans. However, the primary focus of NEWater was and still is for agriculture industry. However, I cannot rule out the possibility of having opening up the availability in the future.
Thank you, Trevor. With that, I think we can bring today's event to a close. I'd like to thank all the participants and presenters alike. As I mentioned, water is a new area for the project, but nonetheless a very important one. And through these presentations, we've gotten an overview of the technology at play, the best practices, and of course, what the institutions are doing as well to support industry. We will be having another webinar in March. I will be in contact to provide some information about it. Right now, we're looking at potentially covering the subject of green loans, which will help companies with their investments in sustainable projects. Thank you, everyone. Wishing you a great day and a lovely weekend.
Thank you very much. Bye-bye.
Thank you.
Thank you.
Thank you.